Hello and welcome to York Observatory YouTube, TeleTube, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'm Quinton, and I'll be one of your hosts this evening. I'm joined by Prayosha, Amin, and Matt. We are broadcasting live from the Alan I. Carswell Observatory located at York University in Toronto, Ontario, Canada. York TeleTube broadcasts every Wednesday night at 7:30 p.m. local Toronto time. But if you have missed one of our streams, don't worry. All of our TeleTube events are recorded and uploaded to our YouTube channel for you to watch at whatever time works for you. If you have any questions about the contents of tonight's show, feel free to ask them in the live chat. We'll try our absolute best to answer them over the course of the night. If you have any questions or comments about our past shows or suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @York Observatory or on Facebook at Alan I. Carswell OBS. Perhaps you tuned in for our March 24th TeleTube, where we talked about the famous Voyager program. Voyager 1 was the first man-made object to travel beyond the edge of our solar system, a real milestone in the history of space exploration. Well, tonight we'll be talking about a different, earlier milestone, the first mission to send a space probe to another planet. Tonight, we're talking about the Venera Program. But before we get started with our main show, we want to give you a little update on what you can see this coming week. The sun will be setting at 7:52 p.m. local Toronto time tonight, so if you're listening to this program in the same time zone as us, you'll likely be able to see the sun nearing the horizon right about now. If you are fortunate enough to have clear skies and a fairly unobstructed view of the horizon, you might be able to see Venus, the star of tonight's show, chasing the sun over the horizon. Venus is extremely bright, so bright in fact that, according to official flight transcripts, there was a famous incident in 2011 where an Air Canada pilot mistook the planet for an oncoming plane, sending his plane into an emergency dive to avoid a mid-air collision with a planet that was, in fact, safely millions of miles away. For other planets, the red planet Mars will also be visible until around 1:30 a.m. tonight, hanging in the sky near the horns of Taurus. The Pleiades star cluster is also located in Taurus and will set around 11:45 p.m. tonight. If you are able to see them, why not count how many stars in the cluster you can see? If you have a telescope, or even a pair of binoculars, you might be surprised at how many of them will be visible. As you can see in this image, the International Space Station will pop over Toronto's western horizon around 9 p.m. tonight and remain just within view for around 2 minutes. If you're willing to wait longer, you'll be able to see some other important objects rising in the eastern sky in the early morning. Saturn will rise around 4:30, followed by Jupiter around 5, and then finally the thin waning crescent of the moon around 6. The next new moon will occur on April 11th. With that said, let's move on to the main event. Prayosha, why don't you introduce the Venera mission with some background information?
Thank you for the amazing watch-out tour of the sky, Quinton. Now, it's time to dive into our presentation for tonight. To begin with, let's take a look at what we are actually heading towards. From learning some quick facts about Venus to events that led us to the Venera mission, let's travel through the entire mission in detail along with the legacy and the learning outcomes. Venus is always called Earth's twin because the two planets are very similar in size, composition, and mass. However, these are two radically different worlds. Venus has a thick and toxic atmosphere of carbon dioxide and yellowish clouds of sulfuric acid, which trap heat and cause a severe greenhouse effect. Its surface is quite rough, and it is the hottest planet in our solar system. The temperature on Venus can go up to 482 degrees Celsius. Unfortunately, it has no moons. This is because Venus is too close to the Sun, and any moon near it would be in an unstable orbit and ultimately be captured by the Sun. Venus has a radius of about 6,052 kilometers and is zero point 0.7 astronomical units away from the Sun. By the way, 1 astronomical unit is the distance between Earth and the Sun. It takes sunlight 6 minutes to travel from the Sun to Venus. Venus and Uranus are the only two planets that rotate backwards, that is, from east to the west. Also, One rotation of Venus is complete within 243 Earth days. But the sun does not set and rise each day on Venus like all the other planets in the solar system. Instead, one day night cycle takes 117 Earth days on Venus. Can you imagine that? This is because, as mentioned above, Venus rotates in the direction opposite of its orbital revolution around the sun. Venus possesses the most circular orbit of all the planets in the solar system, with all the others traveling along paths with a much clearer elliptical shape. Well, I know that was a lot of information on Venus, but catch your breath back as there is more. Let's get through some quick, interesting facts about Venus. Venus was named after the Roman goddess of love and beauty and is often nicknamed the morning star or evening star because its closer proximity to the sun means it can only be seen in the sky just before sunrise or just after sunset. There are more volcanoes on Venus than on any other planet. So far, we have found around 1600 of them. Venus is not only the largest planet of our solar system, but its proximity to Earth and thick atmosphere makes it appear the brightest of the planets in the sky. The atmospheric pressure on Venus is 90 times that of Earth. This is roughly the same pressure you would feel if you were 900 meters beneath the surface of the ocean. If you were on Venus, you would be crushed to the size of a tuna can. The thick atmosphere of Venus appears opaque from Earth, giving no hints about its surface. But with the development of spectroscopic, radar, and ultraviolet observations, many secrets were revealed. The first ultraviolet observations of Venus occurred in the 1920s, and they revealed a lot more surface detail than could be seen in the visible spectrum. The astronomer Frank Ross speculated that Venus was surrounded by a dense yellow lower atmosphere with high, thin, wispy strands of clouds above it, which could be seen through in the UV band, but not with visible light. On the other hand, the spectroscopic observation in the 1900s gave the first clues to the planet's rotation. When measuring the Doppler shift of the light, Westo Slipher first detected no rotation and summarized the observation as Venus having a much longer rotation period than has previously been thought. However, later work in the 1950s proved that the motion was retrograde. In the 1960s, when the first radar observations of Venus were carried out, they provided the first measurement on its rotation period. And in the 1970s, the Venusian surface details were revealed for the first time. This was done by beaming pulses of radio waves on the planet using the 300-meter radio telescope at Arecibo Observatory. The echoes revealed two highly reflective regions designated as alpha and beta regions. It also revealed a bright region attributed to mountains named Maxwell Montes. Before Amin gives us a tour on the Venera mission, I will take you through why we actually had this mission in the first place, other than the limits to observing a distant planet from the ground. During the Cold War, America and the Union of Soviet Socialist Republics, USSR, raced with each other to be the first to reach various important milestones in this emerging field of space exploration, and studying Venus was no exception. The US, for its part, was the first to conduct a successful flyby of Venus with the Mariner 2 probe launched in 1962, which commenced the modern era of Venus exploration by spacecraft. It scanned the planet with infrared and microwave radiometers, revealing that Venus has cool clouds and an extremely hot surface. Mariner 2's predecessor, Mariner 1, has launched 5 weeks before it, with the same mission of performing flyby measurements of Venus. However, unlike Mariner 2, Mariner 1 did not make into space, flying off course during the launch and being destroyed on the command of a range safety officer. The Mariner 2 mission was terminated 20 days after its encounter with Venus, after which point it was left in a heliocentric orbit where it can be still found to this day. While the first spacecraft to perform a flyby of Venus was American, it would be the Soviets who first managed to send spacecraft into the planet's atmosphere and eventually to its surface as a part of the Venera project. I will let Amin explain more about it to you now.
Thank you, Prayosha. The Venera missions are all given a number, and there were 16 total missions. Venera 1 was the first of them and was the second attempt at a Venus mission from the Soviet Union after Sputnik 7, which failed to leave low Earth orbit. Venera 1 weighed 643.5 kilograms and was shaped like a cylinder with a dome on top. It also had 2 solar panels. Antennas were attached in order to send data back to Earth. Venera 1 was launched using a Molniya carrier rocket, which was a modification of the R-7 Semyorka intercontinental ballistic missile. The launch site was the Baikonur Cosmodrome, located in southern Kazakhstan, and the time of launch was 00:34:36 GMT time on February 12 of 1961. Venera 1 was able to gather information about the solar wind and cosmic rays as it was leaving Earth. On May 19 of 1961, Venera 1 conducted a flyby of Venus coming within 100,000 kilometers. Unfortunately, the probe ultimately failed, probably due to the overheating of a solar direction sensor. The mission lasted 7 days. The next Venera craft was Venera 2. It was launched using the same carrier rocket as Venera 1 and from the same cosmodrome on November 12 of 1965 at 5:02 UTC. It had cameras, a magnetometer, solar and cosmic ray detectors, piezoelectric detectors, ion traps, a Geiger counter, and radio receivers. It came within 23,810 kilometers of Venus on the 27th of February 1966. After the flyby, the spacecraft overheated due to a radiator malfunction and communication was lost. The third up to the sixth of the Venera probes were all similar to each other. They weighed around 1 ton and also used the Molniya booster rocket. They were designed to conduct atmospheric measurements, but could not land on the surface of Venus due to the lack of any landing gear. Venera 3 was launched on November 16 of 1965 and aimed to crash land on Venus. On March 1st of 1966, Venera 3 successfully crashed as intended and became the first space probe to touch the surface of another planet. Venera 4 was launched on June 12 of 1967, and it became the first spacecraft to measure the atmosphere of another planet. The Soviet Union claimed that Venera 4 reached the surface of Venus, while later American missions found out that the surface pressure was too high compared to Venera's hull strength. Venera 5 and 6 were launched on 5 January and 10 January respectively in 1969. These spacecraft were designed to enter the atmosphere and descend using parachutes until they got damaged and failed. Both probes recorded just under an hour of data during descent. Venera 7 was the first of the Venera missions that was designed to make a soft landing, or in other words, land and survive. Since it focused on a successful landing, it had to be very heavy, limiting space, and so it did not have many scientific instruments. It did contain temperature and pressure sensors, an accelerometer to measure atmospheric density, and a radar altimeter. It was launched on August 17 of 1970 and weighed 500 kilograms, not including the rocket. Venera 7 could survive pressures up to 18,000 kilopascals and temperatures of 580 degrees Celsius. It entered Venus's atmosphere on December 15 of 1970. During the initial stage where it entered the atmosphere, Venera 7 was attached to an interplanetary bus. Later, the lander part was ejected. The parachute was opened once the probe reached a height of 60 kilometers. Atmospheric studies revealed that the atmosphere was 97% carbon dioxide. 6 minutes later, the parachute began to fail, and Venera 7 picked up speed. Eventually, the parachute completely failed, and the probe crashed into Venus, although it still sent data for a little bit. 53 minutes of data were received, with 20 minutes of it coming from the surface. The surface temperature was determined to be 475 degrees Celsius, and the pressure was calculated to be 9 megapascals, which is 89 Earth atmospheres. Liquid water on the surface of Venus, as well as any chance of human habitation, was thus ruled out. The next spacecraft in the Venera program was Venera 8. It had an atmospheric probe as well as a lander. This time, more instruments were included: temperature sensor, pressure sensors, light sensors, an altimeter, a gamma ray spectrometer, a gas analyzer, and radio transmitters were aboard. Venera 8 was launched on March 27 of 1972, and the lander weighed 495 kilograms. It took 118 days to reach Venus. The bus, which was connected to the probe, had a cosmic ray detector, solar wind detector, and ultraviolet spectrometer. Venera was then released from the bus and reached Venus' atmosphere on July 22 of 1972. A refrigeration system pre-chilled the capsule before entering the atmosphere in order to lengthen the duration of the mission. The descent speed was around 42,000 kilometers per hour, but it was reduced to 900 kilometers per hour using aerobraking. The parachute had a diameter of 2.5 meters and was opened once Venera 8 was 60 kilometers from the surface of Venus. Data was sent during descent and after the landing for 50 minutes and 11 seconds. Eventually, the probe failed due to the intense surface conditions. The previous mission, Venera 7's measurements from Venus were confirmed, and the light levels were also found to be similar to the light on Earth on an overcast day. The next Venera probes, numbers 9 to 12, had a different design from the previous ones. They weighed 5 tons and used the Proton family of rockets. A transfer and relay bus was attached, which had engines and could relay data from the probe. Venera 9 was launched on June 8 of 1975. It had both an orbiter and a lander component. It was the first probe to orbit Venus, and the lander was the first spacecraft to relay images from another planet's surface. The orbiter was cylindrical with wings that contained solar panels. There was also a parabolic dish antenna. Various instruments were aboard, such as spectrometers, photometers, cameras, various detectors, temperature and pressure sensors, and a radiometer. The Venera 9 orbiter lasted 158 days, but the lander lasted only 53 minutes. Venera 10 was launched on June 14 of 1975. It was also an orbiter and lander combination and was built in much the same way as Venera 9. The orbiter lasted 144 days, and the lander lasted 65 minutes. Pictures from Venus were taken and other information was gathered. Venera 11 was launched on September 9 of 1978, and it successfully landed on Venus and lasted 95 minutes. However, the camera lens caps did not release. Venera 12 launched on September 14 of 1978, and the lander lasted 110 minutes. Again, neither camera had the lens caps released, so no photos were taken. Both Venera 13 and 14 had a lander craft and a flyby spacecraft component. They were identical probes. The landers had various instruments and electronic equipment such as cameras, a microphone, a drill, a surface sampler, an electric discharge sensor, and a seismometer. Venera 13 launched on October 30, 1981, and Venera 14 launched 5 days later on November 4 of the same year. Both craft weighed 760 kilograms. It took just over 4 months for Venera 13 and 14 to reach Venus. Both missions had a cruise stage and a descent stage. Parachutes were used to slow down the descent speed. Both probes landed in the same area, just 950 kilometers apart from each other. Venera 13 survived on Venus for 127 minutes, and Venera 14 lasted 57 minutes. Unfortunately for Venera 14, although the camera lens cap was ejected successfully, it landed just under one of the testing arms, which interfered with the gathering of data. Many scientific instruments were included, such as accelerometers, thermometers, barometers, spectrometers, photometers, and others. Information about Venus's surface was relayed. The last of the Venera series of spacecraft, Venera 15 and 16, were just orbiters and did not land on the surface of Venus. They were identical spacecraft. Venera 15 launched on June 2 of 1983 from Baikonur and used the Proton rocket. The mission lasted 1 year, 1 month, and 7 days, 9 months of which were spent around Venus. Venera 16 was launched on June 7, 1983, just 5 days after Venera 15. It also lasted 9 months in orbit around Venus. Both spacecraft entered into orbit around Venus just 1 day apart from each other. Together, they took images from a vast area of the surface of Venus from the North Pole down to 30 degrees north in latitude. They both had a parabolic dish antenna for returning the information that was gathered back to Earth. The list of scientific instruments on board includes radar equipment, an altimeter, spectrometer, cosmic ray detectors, and solar plasma detectors. The synthetic aperture radar system was able to penetrate Venus's clouds in order to take the necessary images. Both the Venera 15 and 16 made over 250 orbits around Venus for the duration of their missions. The final spacecraft that had Venera characteristics were the Vega probes sent to Venus, which used the Venera design. Venera D is a proposed mission from the Russian Federal Space Agency, and it may launch in 2029. The Venera missions established a number of firsts in the history of space exploration. For more on the accomplishments, Matt is up next.
Thank you, Amin, for letting us know the different missions that were planned for the Venera project. But what were the results of these several missions? What did we find on Venus? Well, it actually starts with Venera 4 being the first spacecraft to measure the atmosphere of another planet. Results from the Venera 5 and Venera 6 missions published by the Soviets in March 1970 seem to confirm the sharper earlier findings from Venera 4, suggesting that the planetary atmosphere consisted of 97% carbon dioxide, less than 2% nitrogen, and then less than 0.1% oxygen. Data from Venera 6 suggested that the ground pressure was about 60 atmospheres and the ground temperature was about 400 degrees Celsius on average. This data compared to Venera's 4 readings, which indicated pressure at 75 atmospheres and temperature at 500 degrees Celsius. And as for Venera 7, it didn't only orbit the planet and study its atmosphere, but it was part of the missions that were supposed to land on the surface of Venus. Venera 7 became the first spacecraft to soft land on another planet and the first to transmit data from there back to Earth when it landed on the Venusian surface on 15 of December 1970. The probe transmitted information to Earth for 53 minutes, which included information confirming that the atmosphere of the planet was 97% CO2 indeed, and also recordings of about 20 minutes from the surface. It was found that the temperature at the surface of Venus was 475 Celsius. And using the temperature in models of the atmosphere, a pressure of 88.8 atmospheres was calculated. For Venera 8, it confirmed that the earlier data on the high Venus surface temperature and pressure returned by Venera 7, and also the light level being suitable for surface photography with roughly 1 kilometer of visibility. Venera's 8 photometer measurements showed for the first time that the Venusian clouds ended at a high altitude, and the atmosphere was relatively clear from there down to the surface. The onboard gamma ray spectrometer measured the uranium, thorium, potassium ratio of the surface rock, indicating it was similar to alkali basalt. Another interesting finding that was seen on these missions was the superrotation phenomenon, in which Doppler measurements of the Venera 4 to 7 probes were the first evidence of the existence of high-speed zonal winds of about 362 kilometers per hour in the Venusian atmosphere. Other missions not only landed and tested the atmosphere of the Venusian winds, but also studied the surface and confirmed that what Venera 8 found earlier. Venera 13 returned the first colored images of Venus' surface and discovered Leucid basalt in a soil sample using a spectrometer. Venera 14 took a soil sample which revealed tholeiitic basalt, similar to that found on Earth's mid-ocean ridges. While Venera 15 mapped along with Venera 16 to the northern hemisphere down to 30 degrees from north with a resolution of 1 to 2 kilometers, as it was mentioned earlier by Amin. The study of Venus didn't end with Venera. Au contraire, several missions starting 2 years after Venera 16 till this day have been made in order to understand this planet in detail. One of these missions was the Magellan Mission, which was able to map the surface of Venus using synthetic aperture radar to better understand the topography of the planet. It managed to image many areas in multiple times, with 98% of the surface mapped at resolutions better than 100 meters. Data from the planet help with scientific investigations into the planet's interior and studying plate tectonics, impact craters, and erosion on the surface. Other mission that successfully studied the planet was the European Space Agency's Venus Express, which was the first successful Venus orbiter mission, successfully launched by any country besides the Soviet Union or the United States. The overall goal of the mission was to study the atmosphere and plasma of Venus from orbit starting in 2016 and 2006, I'm sorry, and ending in 2014. The mission had many investigations, some of which included looking at the greenhouse effect on Venus, how the atmosphere reacts to the solar wind, and properties of the Venusian magnetic field. And this was not the only mission that was held by other countries besides the Soviet Union and the US, because in 2016, the Japanese Aerospace Exploration Agency successfully studied the Venusian climate with the Akatsuki mission, where one of the interesting reveals confirmed the phenomenon discovered by Venera first, which was that Venus' whole atmosphere is rotating much faster than the surface below, at the altitude of the cloud top, a unique situation called superrotation. In the future, we expect to have more missions that will continue to study Venus and even land on its surface again. Two main missions could be the Veritas and the Da Vinci Plus mission, where Veritas would send a probe to orbit Venus and map its surface, while Da Vinci Plus would send a probe down through the planet's atmosphere. That probe would take samples of the air on the way down, potentially telling us more about what is lingering in the clouds. Moreover, there is a new Venera mission coming into play possibly in 2026, 2027. The VEXAC or Venera D mission will be in charge of the study of the planet's atmospheric dynamics, as well as the surface geology and chemistry. More nations are planning to study this planet, and we'll see what new discoveries we may find laying on the atmosphere and surface of this majestic and mysterious planet. And everyone, you have been listening to the Alan I. Carswell Observatory's weekly TeleTube broadcast, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Quinton, Prayosha, Amin, and myself, Matt. Make sure to leave any comments or questions in the comment section of the video and talk to us in the chat right now. We will be around for the next 20 minutes to answer your questions. All of our programs are free, but if you would like to buy an observatory calendar or make a donation, see our website at observatory.info.yorku.ca. You can always connect with us on Twitter with the handle at York Observatory and check out our website for show notes, content, updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in. Clear skies and have a good night.